Okay, so we're going to shift gears. Now is where we did all this envelope work. That was our emphasis. Now we get to take advantage, we get to reap the benefits, basically, of our insulative high envelope, high performance envelope work. Because now this is the stuff that costs money to operate. I mean, your insulation doesn't generate a gas bill or an oil bill. It's the systems that are in your house running. So now that we've downsized the heating load of the house by like 60, 70%, we now have to have a strategy for doing the following to the house. We want to space condition it, we got to water heat it, and we got to get this distributed to the house, and we got to bring in whole house ventilation. So the housing stock that we dealt with had ductwork. I showed you that furnace. That was typical of all the houses we dealt with. And we screened, we initially intended to do 12 projects. We were able to do like the 5 houses, the 2-family, because of basically the costs and what we learned going in, so we scaled back. But of all those houses, every one of them had ductwork. So it was heated with a furnace. So to avoid yet an additional expense of converting everything to hydronic, and we need the ductwork for the mechanical ventilation, we came up with what we call a fan coil. And we use a fan coil is similar to a furnace, but it's much, much reduced. A fan coil asks for about 45,000 BTUs per hour, or can deliver, as opposed to the furnace, you'll remember, was 250,000 BTU, like 6 big burners in there. So this allowed us to marry up to the existing ductwork once we optimized it, provide hot water through a tankless hot water heater, and use one loop off that tankless hot water heater to feed the fan coil. And that provided the entire house. And that's, I mean, you'll see that's where the savings come from. The footprint is much smaller. I mean, a tankless hot water heater, you can put it in a closet. But since they had basements and furnaces, we married into that. Resized the heating equipment, and that basically, that's what we concluded was the best solution, using a tankless hot water heater.
So 200,000 BTU to sort of
40.
Less
Yep.
because of the insulation.
Yep. That's the benefit. That's basically that's your hurrah moment when you get to when you've built the envelope or optimized the envelope. So now you can take advantage of much, much, much smaller equipment. And this is where we have a big disconnect in general in our country. Equipment systems are sold on size and request. And housing envelopes don't typically meet anything of what we set these bogeys at. So to be safe, mechanical contractors put in systems that will deliver the most amount of heat on a design day. And a design day is like the day of the year that it's 22 below zero and the wind is blowing at 40 miles an hour. Now that might only happen once in 7 years, but the mechanical contractor, to be fair to him, he wants to make sure the customer is always satisfied. So he winds up sizing a system to meet that one day. With the loads we've optimized, we're never near that day. We have that same day, but the load that we have to satisfy has been such drastically reduced, we don't have to consider the size of the equipment.
And if you reduce that heating load in half again, would you still use a similar approach?
Yeah, because you got to make hot water. I mean, people are always going to need hot water, and I'm glad they will. Because, so the thing that happens is you have to determine, I like to have one fuel source in the house. Some people don't even like to have combustion. So a lot of people would argue get the house even lower and use electric heat. You know, heat it with some, you know, space heaters and then have an electric hot water tank. But,
unit,
yeah.
combustion's a non-issue.
Right,
I
right.
mean, it's
So
just philosophical.
it's a philosophical, but keeping the fuel source minimized is an objective here. So these people were on natural gas, so we had the advantage of having a hot water system that could also make the space conditioning, do the space conditioning. In an environment that doesn't have natural gas, all tankless hot water heaters, they have a propane conversion kit, so that's not an issue. If you want to avoid the fuel and like have a wood stove, tankless hot water heater for your hot, and then maybe run it through a heat exchanger off the wood stove. But then you're kind of you're married to having the wood fire going.
And then you get into
Combustion issues. Yep.
And
Yep.
have you run across a system where you can really bring direct air to a wood stove?
Not yet. And point source heating is also a decent solution. But again, these houses already had ductwork, and we needed to provide mechanical ventilation to them. So we're not going to eliminate the ductwork.
And since we go back to wood stove one more time, where we have like the prefabricated fireplaces, which are can be a better unit.
Mm-hmm.
They have outside air. Would you consider something like that in a very tight house? Because up here, that is a very logical source of fuel. And
Yeah.
why would I want to pay for fuel?
Yeah.
If I'm bringing my load down to 40 or 20,000 BTUs,
Yeah. Yeah.
you know, a nice little stove
Yeah.
that's on a few
Yep.
hours. And
Yep. It's not off the table.
It'd be too hard to bring air to
Well,
that
is
stove.
it
No, it's
quite-
not. You can actually, when you design your HRV or ERV, you give it a dedicated port. You give the combustion device a dedicated airport to be safe. Yep.
You didn't use any solar for any of the hot water?
No, but it could have been done. I mean, that's another option. There's ports on the fan coil unit to take solar to augment the tankless. But usually with solar, you still need a device. I mean, you can't rely on the solar heated hot water for 100% of the load. And we were trying to, I mean, this was a research project, but we had functioning inhabitants in these homes, and I didn't want to, like, deluge them with tons of new technology. I mean, I tried to make most of the solution for them was a passive solution. I mean, as far as they know now in their basement, they still have a furnace. They have a filter to clean once in a while on their whole house ventilation system. That's basically the only added maintenance that we made for them, and they actually had that same filter on a furnace, on the furnace.
So your water heater and your furnace are separate units in this?
Nope.
This solution?
No,
they're not.
you'll see. So we use a tankless, high-efficient hot water
the whole
heater.
thing.
There's several of these now. I mean, these have been out a while. They got a bad name in some areas of the country where the water was really hard, but there's methods of dealing with the water hardness. You can screen it, you can filter it, and an annual flush of a hot water tank like this with a vinegar solution, it's like a 20-minute operation. There's actually a YouTube video I've referenced in here, is something you can do to these systems. So these are solutions now. They've been around long enough, they've been vetted, and this can provide a very good, it's like a small boiler.
Am I right in thinking there are actually two tankless heaters in this thing?
We have a mixing valve. We have a mixing valve to change the temperature for the space heat.
I'm thinking of the fact that the water that goes around, the water that's used to,
We just take a loop out of this for this fan coil.
okay, it's the
And there's a
same-
schematic.
It's the same water.
Same? Yeah. No, they're separated. They're
There's
separated.
2 loops of water.
2 loops of water, yes. So this is a high-efficient water heater. This happens to be a Phoenix. There's also a Polaris. When we were working with the building science team initially, Mark Rossenbaum gave me advice on these types of units. These cost like $3,000. They're insulated. They're a stainless steel tank. So very expensive. We just spent a lot of money on the building envelope. We want to try to use the savings. We want those savings to fall down onto the mechanical reduction. I certainly didn't want to spend it on a $3,000 hot water tank. So we used the tankless system. and we added a buffer tank just to be safe. The little buffer tank is an electric tank, but we don't connect the electricity. We just use the tank as a device for storage. This is for the day that 3 showers are taken in a row, it's 10 below zero, the furnace is running, the fan coil is running, and somebody's washing dishes. So we just wanted that insurance of having to be enough hot water at both systems. So in this diagram, you see the check valve, basically the red, that's where we isolate the 2 different loops. We have potable water that comes out of the loop and goes to the fan coil, and then that's purged periodically. So there's no concerns with open air, oxidation, Legionnaire, all that kind of stuff that people get concerned with when there's an open loop system being mixed. And then the other is the domestic hot water.
Can you rattle off the names of those manufacturers?
Rinnai is one, Rinnai. Navien, Navien.
Well, there are a bunch of them.
Yeah, those are the 2 that come to mind right now, but I mean there's many systems. The Rinnai is nice because it couples with its own fan coil unit.
Where is the air being, the heat exchanger to the air system?
It's in the furnace, and I've got a picture. Yep. So we connect one of these loops from the tankless to a fan coil. This is pretty much what a fan coil looks like. Similar to a furnace, but just much more reduced. Lots of stuff about a fan coil. Another benefit in here, the fan coil, because you're moving a much smaller volume of air, you don't need that 600-watt blower motor that I mentioned earlier in the furnace. You're now using like 1/25th of a horsepower motor and an ECM, electrically commutated, it's a magnetic pulsing motor, draws hardly any electricity, and it just moves the air very slowly to the register vents. Because the house is, it's more stable. I mean, the heat that these houses are making now, one of the homeowners was telling me last winter, I mean, she brings her house up to temperature, like in the morning when her grandkids go off for the day, it stays there. I mean, because the leakage has been reduced so drastically. So it's not like this blower motor needs to like come back on every 25 minutes.
But it is running longer, just because of...
Usually, actually, that's a better thing because it exhausts, it takes all the hot air off the fan coil and moves it out. It like kind of discharges it rather than short cycling. Yep. This is the schematic of using fan coils, and this is again with the application of the big tank, which we didn't use. I've got schematics. There's the fan coil unit. So it aligned right with the furnace ductwork. We brought that new piece down as the intake, or the return, I guess you'd call it the return. But all the supplies, we married into the ductwork that they had. We did seal it. We sealed it to less than 3 CFM per 25 Pascal, measured at 25 Pascal. So basically, we took care of leakage, because now we certainly don't want leakage in the ductwork, because that will be amplified if we're trying to distribute air. We got to add whole house ventilation. So now we have to, this is a configuration that shows how to integrate whole house ventilation in with a fan coil and utilize the same ductwork. Easier said than done. This is a device, a unit made in Canada, New Air. The company is, that's the product. The name of the company is escaping me right now. But basically, they've integrated the ERV right in with the fan blower device. So you don't have to have 2 units. So the heat exchanger is on the bottom. Everybody understands whole house ventilation, what happens? It brings air in from the outside, and before it delivers that air to your livable spaces, it crosses with air that's being sucked from, say, your bathrooms and kitchens, air that you want to discharge. But the advantage is it's taking the heat out of that air that you already spent money making in the house and introducing it to the incoming air, fresh air that's going to get delivered. So you have a better ratio. Because one of the problems with taking air out of your house, one of the arguments could be, well, my God, you're exhausting air that I just spent money to condition to my temperature. So by bringing it, by crossing them in that core, it optimizes the temperature gradient. Typical HRV, I mean, basically there's an inlet port, an exhaust port, and then discharge ports to the fresh air. Like typically you put fresh air returns to the bedrooms, and you bring returns from areas where you're cooking, bathrooms. Like in our house we have timer. If I go to take a shower, I turn the timer, it throws the fan into higher speed, it pulls the moisture out of the bathroom and then shuts off. It shouldn't say shuts off, it reduces back down to the low speed, which is always circulating the air.
Continuous exchange?
Yeah, it runs all the time. I turn it where we live, because we're in the Adirondacks, we use our windows in the summer. But, I mean, some people, they're in a city, they don't want to do that. You can run it continuously. I monitored mine one year. I monitored it for 3 months, and I extrapolated it, what it would be over a year. It was costing me about $90 a year to run, if I ran it year-round. And I had to have a dual core. I have a dual core unit, so it's got a little bit bigger motor. The power is 1/25 of a horse. So 1/25 times 746 watts per horsepower. Very little. You can put it into an outlet, and that outlet can have many other circuits off the breaker. About the good ones now are like 85 to 90%. So that just means you're losing 10% of that air in the exchange that you heated up. This is the inside core, yes.
The heat recovery ventilator.
Yep.
Isn't that something that all houses could benefit from, even if they don't have the deep retrofit in place?
Yeah, it depends though, because some houses, if they're hydronically heated and they haven't run any ductwork, the ductwork is, that's still an obstacle. So people are reluctant to put in ductwork when they try to avoid the ductwork by having a hydronic system. So it's kind of it has to be something you think about as you're doing your project.
It has to be distributed, you're saying?
Yeah, you got to balance it. You can't just put one of these up and throw a couple of ports in the kitchen and throw a couple of ports in the, and it's fairly easy to balance. There's a gauge, and you run it, and you test the airflow, and basically you want to deliver a certain amount of CFM because remember, you've reduced the leakage of the house a lot, so you're living in a pretty tight box. What you're trying to do is bring in enough air for the occupants. There's charts based on how many people you have, how many dogs, if you have plants, stuff like that.
As I remember, the figure for total exchanges per hours is shockingly high.
Yeah. It does a good return. It's fresh air. I mean, the year we fired ours up in the new house we built, we were painting the interior, and my wife was commenting. I mean, we had low VOC paint also, but she was commenting that we were sleeping in the house the nights we were painting it.
Well, what amazed me about it was that we need that much of an exchange of air. In fact, you think if you're exchanging it that many times, good Lord,
yeah,
wouldn't our heating bill?
Well, that's where the efficiency of the unit, like he asked, comes in. Because you're grabbing the heat that's heading out the door, which in a leaky building, you're not doing that. This is a great slide because this was some comments we've made after one of the projects where they installed. This has the fan coil units, and then the separate HRV got installed. They made a lot of mistakes, and it's a great learning opportunity. Today's Thursday. I think they're actually there today in Utica at the Taylor Ave project correcting this. But it's an example of these are the HVAC contractors. They're just not familiar with this type of technology. They just basically messed up a few of the returns and supplies, and once we get those back, we'll have it balanced and running properly. So it's a great opportunity for workforce. as a portfolio. As we get better houses, we get them tighter, we get them mechanically ventilated, HVAC contractors or others, it would be great for them to delve into this, this arena. This is just things to be, the old concerns of taking tankless hot water heaters, because a tankless hot water heater, the orifices are small, there's a very small flow meter in there, it gets its supply from gas, so it's a combustible device, so for safety concerns, if it doesn't sense any water, it shuts down. I mean, there's a lot of conditions, and scaling of your pipes can cause these things to be problematic. So these are things to take care of. So we use the existing ductwork. So this is just some of the conditions we had to take into account with the existing ductwork. It needs to be insulated if it's in the unconditioned space. We cleaned it.